Lattice enthalpy and the factors.
Bismillahirrahmanirrahim. Guys, we are going to start today A2 chemistry. A2 केमिस्ट्री में होता क्या है, पहले ये डिस्कस करते हैं। इसमें दो पेपर्स होते हैं। एक होता है पेपर 4। पेपर 4 होता है स्ट्रक्चर्ड क्वेश्चंस का। जिसकी वेटेज तो 100 मार्क्स है और ड्यूरेशन 2 आवर्स है। 5 6 7 8 9 क्वेश्चंस होते हैं इसमें। और A2 में इसकी परसेंटेज जो है ना, अबाउट 38%। इसमें फिजिकल केमिस्ट्री के 4 चैप्टर्स या 5 टॉपिक्स हैं। 2 चैप्टर्स 2 टॉपिक्स इनऑर्गेनिक केमिस्ट्री के हैं। उसके बाद ऑर्गेनिक केमिस्ट्री है। ऑर्गेनिक के बाद एनालिटिकल है, जिनको हम एप्लीकेशन टेक्निक्स भी कहते हैं। फिजिकल केमिस्ट्री की जो वेटेज है अबाउट 40% है। इनऑर्गेनिक की अबाउट 15% है। और इन दोनों की परसेंटेज अबाउट 45% है। दिस इज अबाउट P4 एंड देन P5. P5 is about the planning, analysis and evaluation. 30 मार्क्स के हैं। 2 क्वेश्चंस यूजुअली आते हैं। वन इज अबाउट द प्लानिंग एंड द सेकंड इज अबाउट द एनालिसिस एंड एवेल्युएशन। तो 30 मार्क्स है, इसकी परसेंटेज बनती है 12%। और इसका ड्यूरेशन होता है 1 आवर 30 मिनट्स। These are 2 questions. नेक्स्ट, तो जो हमारे P4 में टॉपिक्स हैं, P4 के लिए जो पहला टॉपिक है दैट इज अबाउट एनर्जेटिक्स। एनर्जेटिक्स में इस ये कंटिन्यूएशन है आपके एएस की, जहां पे हमने एएस छोड़ा था एक्सोथर्मिक एंडोथर्मिक इंथैल्पी चेंज ऑफ, ये एएस में हमने पढ़ा था। व्हाट इज अबाउट एंडोथर्मिक एंड एक्सोथर्मिक रिएक्शंस, एनर्जी प्रोफाइल डायग्राम्स, एनर्जी प्रोफाइल डायग्राम्स। उसके बाद इंथैल्पी चेंज ऑफ फॉर्मेशन, enthalpy change of reaction, enthalpy change of reaction, enthalpy change of neutralization, and then we have done bond energy. This is what we've done in AS. And now we're going to Enhance law. In A2, we'll be doing a bit more than this. That is enthalpy change of lattice, enthalpy change of hydration, enthalpy change of solution. इन तीनों को हम डिस्कस करेंगे। स्टैंडर्ड enthalpy change of lattice, hydration and solution. उसके बाद enthalpy change of atomization, यूं भी लिखते हैं इसको और यूं भी लिखते हैं और यूं भी लिखते हैं। They all are right. Enthalpy change of atomization and the relationship of enthalpy change of atomization and bond energy in the reference of fluorine, chlorine, hydrogen, lattice enthalpy. Standard under standard conditions. So what is the definition of this enthalpy? Let's see. Is the enthalpy change it is the enthalpy change when 1 mole of ionic compound is formed from its gaseous signs from its gaseous ions. It is the enthalpy change when 1 mole of ionic compound is formed from its gaseous signs under standard conditions. Under standard conditions. And one example for this is example 1. If we got to write down the equation for the enthalpy change of lattice of sodium chloride, what do we have to write it down? It means 1 mole of sodium chloride is formed. Sodium chloride is solid at room conditions from its gaseous signs, sodium ion and chloride ion, gaseous signs. We can't write down like this. This would be wrong, yeah? What is wrong? Na gaseous plus Cl minus 2 half. This forms NaCl. This is wrong. We can't be using this one. This is totally wrong. We cross it. Gaseous ion under standard conditions, yeah? Example 2. Enthalpy change of lattice of magnesium oxide. So what is the equation? 1 mole of magnesium oxide is formed from its gaseous ions. Two plus. Similarly, example 3. Enthalpy change of lattice of aluminium oxide. What would be the equation? Write on the equation for the which represents enthalpy change of lattice of aluminium oxide. You got to write on like this. 1 mole of aluminium oxide is formed from its gaseous ions. Now we learn a bit more about lattice enthalpy. Remember one thing. The value of enthalpy change of lattice is always exothermic. Larger the value of enthalpy change of lattice, stable will be the ionic lattice. More stable or stable will be the ionic lattice. Secondly, we don't need to know how much negative, like how much energy is released when the ionic crystal is formed. They're going to be giving it to you. So we don't need to learn the exact values. Enthalpy change of lattice. Now we do some factors affecting enthalpy change of lattice. Factors affecting lattice enthalpy. Let's find out the factors. What could be the factors that can affect the enthalpy change of lattice? अभी देखते हैं. पहला factor क्या हो सकता है? What does the enthalpy change of lattice represent? Lattice enthalpy is a measure of the strength of an ionic compound or ionic bond of ionic bonds. It is influenced by the following two factors. It is affected or influenced by the following two factors. कौन-कौन से factors हैं? Number 1, charge on the ion. And number 2, size of the ion. In AS, we have done the combined effect of these two factors give charge to size ratio. You are familiar with this. Charge to size ratio. We can call it ER ratio. It is also known as the charge density, charge to size ratio, or charge density. Now, if ER of a cation or anion is greater, ER is greater, then what happens? ER is greater, lattice enthalpy will be more exothermic. Or we can say like this: higher the charge, and smaller ionic radius, results in stronger electrostatic attractions between oppositely charged ions. Okay. Higher the charge and smaller the ionic radius results in stronger electrostatic attraction between the oppositely charged ions. What does it mean? Let's see in here. We know one thing. We done this in AS. ये जरा याद रखिएगा. AS में हमने कहा था ionic radius of period 3 elements. See, it was something like this: sodium ion, magnesium ion, aluminium ion, silicon ion, and then phosphide, sulfide, chloride. Sodium ion, magnesium ion, aluminium ion, silicon, phosphide, sulfide, chloride. So you see, in chloride ion is in the same way. If we go to the period 2 elements, they're going to be very similar as well. This is lithium, beryllium, boron, carbon, nitrogen, nitride ion, oxygen, and fluoride ion. Ionic radius. We've done the period 3 elements in AS. Now we're doing this one. This is period 2 elements, yeah? Period 2 elements. And this is period 3. Now we compare these 3 compounds: sodium chloride, magnesium oxide, aluminium oxide. Sodium chloride, magnesium oxide, and aluminium oxide. What we expect from these to be, what the enthalpy change of lattice, this value of the enthalpy change of lattice of these 3 compounds is going to be more negative, more exothermic. It would be sodium chloride. Sodium ion is quite bigger, and chloride ion is very big as well. Instead, the charge on sodium ion is +1 and chloride ion is -1, which is smaller than as compared to the magnesium ion. The size of magnesium ion is smaller, and the size of oxide ion is quite smaller. So then this one, similarly, aluminium ion is even smaller. So aluminium ion has the apart, in these 3 compounds, sodium ion, magnesium ion, and aluminium ion. Let's see in here now. इनकी charge density compare करते हैं. One thing is that we get the exact value of their cations, the radius, a value of the radius of the cations. But one we suppose it, yeah. Sodium के ऊपर charge क्या +1, magnesium का +2 charge, aluminium का +3 charge, and their sizes. इधर देखते हैं. Say that sodium ion का size is the biggest, yeah, biggest. तो हम कहते हैं इसका size 1 है. And the size of the cation, magnesium cation, says this is 0.5, bit smaller than that, and aluminium is smaller, even smaller. So what is the charge density? ER ratio. If we compare the ER ratio in here, आप बताएं क्या होता है? Sodium की ER ratio बनेगी 1, magnesium की 4, and aluminium की 12 बनेगी. Yep. तो charge density किसकी ज्यादा है? Aluminium. So ionic attraction between aluminium ion, so we can write down ionic attraction between aluminium ion and oxide ion are greater than those present between magnesium ion and oxide ion. And ionic attractions between magnesium ion and oxide ion are stronger, greater or stronger than those present between sodium ion and chloride ion. It depends on the charge density. Got it? अब देखते हैं question. Now we move to a question. If the question comes like this, if this is the question, usually we get these kind of questions. State how enthalpy change of lattice of sodium sulfide is different from enthalpy change of lattice of sodium oxide, and then explain your answer as well. अब जरा इसको कंपेयर करते हैं. Let's see. Answer for this question is now compare these two things. Sodium is the same, yeah, and oxide ion is here, and this is sulfide. Oxygen and sulfur are in group 2. We know that as we go down the group, the size of ion increases or decreases as we come down the group, yeah, increases. So the charge density definitely decreases because the charges are the same, -2, -2. So हम क्या कह सकते हैं? Let's see in here. Enthalpy change of lattice, point 1. Enthalpy change of lattice of sodium sulfide is less exothermic than, obviously, than that of sodium oxide. Then that of sodium oxide. Why is that reason? Here comes the reason. This is like you stated, it is less exothermic. And the reason is the size of sulfide ion is bigger, is larger or bigger than oxide ion. So the charge density of sulfide ion is lower or is lesser, than that of oxide ion. Number 4, hence the ionic attractions between sodium ion and sulfide ion are weaker. Next. So we have seen it. Hence, the enthalpy change of lattice is less exothermic in case of sodium oxide. That's it. Question number 2. Now we do question number 2. Now question comes, state how, very important question, a new concept comes in here. State how enthalpy change of lattice of calcium chloride is different from enthalpy change of lattice of calcium chloride. Let's see in here. सबसे पहले तो हमने सल्फाइड आयन एंड क्लोराइड आयन के साइजेस देखने हैं. And we seen the sizes. क्या साइज है? सल्फाइड आयन is bigger than that of chloride ion. तो कैल्शियम क्लोराइड की तो more exothermic होनी चाहिए ना. So the answer, okay, I write down the answer, but it's going to be wrong, yeah? This is wrong answer. Most of the students might write it down. Enthalpy change, we're stating now, and explain the answer. We know one thing. Sulfide ion is bigger than that of chloride ion. How do we know? We done it here. Look at this one. Sulfide ion. The question ये भी आ सकता है कि why sulfide ion is bigger than that of chloride ion? क्योंकि sulfur में 16 protons हैं, chlorine में 17 protons हैं. That's why in chloride ion, the attraction of the nucleus is more on the outermost electrons than the outer electrons or outer shells. That's why it shrinks a bit. तो ये आंसर हम AS में पढ़ चुके हुए हैं. There we are now. अब हम ये देखते हैं. So enthalpy change of lattice, I'm writing enthalpy change of lattice of calcium chloride must be more exothermic. Yep. It should be more exothermic, but this is wrong. Why is that? And the reason is that here comes something else. अभी देखते हैं what that comes. अभी डिस्कस करते हैं कि सल्फाइड आयन में चार्ज क्या है. सल्फाइड आयन में चार्ज 100% बिगर है, बट नॉट द साइज. साइज क्या है? साइज भी हम डेटा बुकलेट से चेक करते हैं. सल्फाइड आयन का साइज क्या है? size is not 100% double, yeah? Just a second. Here. Now we are here. The size of sulfide ion is 0.184 nanometer, whereas the size of chloride ion is 0.181. Now we check, is the size decreased by 100%? Size is not decreased, but we know the charge has been increased by 100%, yeah? The increase in the charge is much more. That's why the charge density of sulfide ion is much greater than the charge density of chloride ion. That's it. I repeat, I write it down like this now. We can say that answer. Enthalpy change of lattice of calcium sulfide. This is calcium sulfide. Calcium sulfide is more exothermic enthalpy change of lattice of calcium sulfide is more exothermic than that of calcium chloride. Next. Because the charge density of sulfide ion is greater than that of chloride ion. Sulfide ion की charge density क्यों ज़्यादा है? Because it has double charge. The charge is 100% more than that of chloride ion. So the ionic attraction attractions between calcium ion and sulfide ion are stronger than those present between calcium ion and chloride ion, than those present between calcium ion and chloride ion. अब यहाँ पे एक छोटा सा note लिखते हैं. What is that note saying? Let's see in here now. And the reason for this is, though the size of chloride ion is smaller, but the change in charge is more significant. And the reason is, that is 100%. And that is 100%. That is 100%. So the charge density of sulfide ion is much greater than the charge density of chloride ion. Next question. Question 3. Suggest the trends in the magnitude of enthalpy change of lattices or lattice energies of silver compounds, the following silver compounds, and explain your answer. Answer for this is, what are those compounds? They are Ag2O, Ag2S, Ag2Se. We know one thing. Now we're doing the answer. Oxide ion, sulfide ion, and selenide ion. Yep. Which one is the biggest? The lower one is the biggest. So ionic size is increasing, and ionic size is increasing down the group. So charge density is decreasing. So we say this is more exothermic than this. This is more exothermic than this, and Ag2O is more, silver oxide is more exothermic. Enthalpy change of lattice of, so we say enthalpy change of lattice of silver oxide is more exothermic than enthalpy change of lattice of sulfide ion, that is more exothermic than that of Ag2Se. So you got 1 mark for this. The next mark is coming now, and the reason for this is ionic radius increases from oxide ion to Se2 minus ion, selenide ion. Selenide ion. Number 2, the charge density of group 6 anions decreases. Anions decreases down the group, downwards. So ionic radius is increasing from oxide ion to selenide ion, but the charge density is decreasing. Hence, ionic attractions between silver ion and oxide ion are the strongest, are stronger than those present between silver ion and sulfide ion, which are more stronger than, and these are more stronger than those present between silver ion and selenide ion. That's it. Or even we can say that for the third point, we can even say that ionic bond between silver ion and anions, group 6 anions of group 6. I repeat, the ionic bond between silver ion and anions of group 6 becomes weaker down the group. So whatever we have done so far, we go for the summary of that. We have done we have done lattice enthalpy of ionic compounds. What is lattice enthalpy? Is the enthalpy change when 1 mole of ionic compound is formed from its gaseous ions. 1 mole of ionic compound is formed from its gaseous ions. Then we said whether the factors affecting the enthalpy change of lattice, 2 factors: charge on the ion and size of the ion. And these two factors give a combined effect. What is that called? Charge density. We said greater the charge density, greater the charge density will be the enthalpy change of lattice. Lower the charge density, enthalpy change of lattice will be lower or more exothermic here and less exothermic here. That's all. Okay.
Thanks for watching. Please like and subscribe.